So the big picture for this lesson is inverse functions. And here I have two functions, f of x equals 2x minus 1, and g of x equals 1 half x plus 1 half. These functions are inverses. How do we know? Well, there are a few different ways to tell. I'll show you all of them. First of all, with an inverse function, the inputs and outputs are switched. You can see the inputs for x, negative 1, 1, 3, and 5, are the outputs for g of x, negative 1, 1, 3, 5. And same thing, the outputs for f of x are the inputs for g of x. So the inputs and outputs are switched. Also, if you look at the graph, I plotted the points for f and for g. There's a pattern with inverse functions. All inverse functions reflect through the line y equals x when they're graphed. And you can see here that there's a reflection between that line with all these points, except for 1, 1, which lies on the line of reflection, so that point is going to be itself. And that should make sense because if the input and output are the same, if you switch them, they're still the same. Another way you can tell is you can do a composite function. So f of g of x. If that equals x, then you know you have inverse functions. So let's try that. I'm going to take this g of x and put it inside the f of x. So it's going to be like this, 2, and then 1 half x plus 1 half, then minus 1. So if I simplify this and I get equals x, I'll know I have inverse functions. So let me distribute the 2 first. 2 times the 1 half, that is simply 1. So I'm going to get an x for this distribution. Plus 2 times 1 half again. 2 times 1 half is 1, so plus 1. So it's x plus 1, then minus 1. Well, x plus 1, then minus 1 just makes x. So f and g are inverse functions. And what this means is that you're kind of undoing the original function. My f of x, you take x, multiply by 2, and then subtract 1. Well, to undo that, you multiply by 1 half and then add 1 half. So the last question is, well, how do you solve for an inverse function? Well, what I like to do is write it as y equals, say, 2x minus 1. And then basically what you do is you just solve for the other variable. So I can add 1 to both sides, so y plus 1 equals 2x. Divide both sides by 2. So I get y plus 1 divided by 2 equals x. And what you need to do at some point is switch the x and y variables because you're switching the input and the output. So you'd need to have x plus 1 divided by 2 equals y. And some people like to do that. This is the very first step, and you're welcome to do that. So simplify this some more. So I'm going to split up this fraction here on the left side. So it's going to be x divided by 2 plus 1 half equals y. And I'm hoping you can see now where that 1 half x comes from. This x divided by 2 is 1 half x. So 1 half x plus 1 half equals y. Okay, one final thing. Not all functions have inverses. Let's say I just have a basic parabola. Well, if I try to reflect that through the line y equals x and find the inverse, what happens? What happens is it ends up being a sideways parabola, kind of like that. And then this doesn't pass the vertical line test. So there are ways to deal with that too. You can restrict the domain, and I think that's shown in the lesson too. So that's a real quick summary of everything you need to know about inverse functions.